they're chemtrailing. That's neat. Damn, and we're just so close to the asteroid coming in. Where the hell did he go? It's got a filter. Gee, it doesn't bloop no more. Yeah, let's follow this trail back. Kind of got merged into that other pre-existing. There's this contrail. Or chemtrail. Yeah, chemtrail. There we go. See? One next to the other. I'll bet you it's a binary mixture. Let's see if we can zoom in on a little prick. I missed them, sorry. Oh, I can watch the chemtrail dissipate. So the big mystery asteroid that apparently was coming from the north, not the south, like 2012 MD-14, appeared to have been about a quarter of the size. This is what NASA just put out. Probably about 380 kilotons on the main impactor. It's split into pieces, of course, 4 main impacts. Can you imagine if the half a football field size one coming in about 10 minutes? Yeah, let's just leave the camera on. This will be about 2 minutes ago spray, 3 minutes ago. Had collided, or some of its fragments collide with the incoming, how they can change its course and break it up and everything else that you don't want to see. I'll include some links right there and there. That's the live NASA feed. There's the sun. Don't want to cook the lens. Let's see if I can't do something with that. Don't knock that off, Cindy. It's tracking upwards. Now Bateman is I believe the eastern part of Australia. It's operated by a hobbyist. His name is David Carol, and he is a retiree who actually is very interested in this and has become a bit of an expert. The second one is in Sanford Valley. It's called the Sanford Valley Observatory. It's outside of Brisbane. And here you see it on his telescope tracking down. And the person who operates this, again, a hobbyist, his name is Jonathan Bradshaw, and he has his telescope right by his house, he tells us. And there you see that one. The telescope that we will be relying most on is
That's NASA.
Gingen Observatory.
With their live feed of the asteroid. I'll just finish up here and we'll go have a couple of looks.
About an hour out of Earth, and it is on the western side. And there you see it. This is actually a live image from Gingen right now.
You can copy NASA stuff because if it's for educational and you're not
And we will be talking to
trying to make advertising money off of it.
The person operating the telescope right now is Rick Tonello. Paul Woods is also there. He's their IT guy. And later on, in just a few moments, we'll be speaking to
So there's the chem trail. Is it a binary? I don't know. All I'm getting is a glare on my view screen. Oh, there's a bonus. Let's see if we can get him. Yeah, no point even trying. I can't see dick all.
Asteroid 2012 DA-14 is an object about half the size of a football field in diameter.
So, there's one last look at the trail.
Coming from the south to the north,
Mixing with the slightly older trails.
17,200 miles of the Earth's surface will pass inferior to the geosynchronous satellites from the GPS satellite. If there's been no change, the asteroid hitting the Earth and very little change from the head of the satellite. Although this object is very close to the Earth on February 15th, it's fairly small as asteroids go, and it won't be observable with the naked eye, but if you happen to be located in Eastern Europe, Asia, Australia, and you know where to look, and you have a pair of binoculars, you will indeed be visible. The asteroid was discovered by a group of Spanish astronomers in the Sagra Observatory in southern Spain.
Let's go have a look.
June 30th, 1908, the so-called Tunguska event. An object about 30 or 40 meters came down into the Earth's atmosphere and exploded, leveling trees for 820 square miles. The close approach of this object 2012 DA-14 on February 15th is nothing to worry about. Its orbit is very well known. We know exactly where it's going to go, and it cannot hit the Earth. 20 years ago, we probably wouldn't have found this object, but now NASA's observing the skies nightly and picking up these objects, and we track them for 100 years into the future and see if any of them make interesting close Earth approaches, not only because of the threat issue, but because these objects are important for science, they're important for future resources, as well as threats.
Right now, I am joined by Paul Chodas. He's a scientist in NASA's Near-Earth Objects Office. And Paul, we probably have to address right off.
Asteroid took out the communication satellite for NASA's live feed. There's the countdown, 20 minutes, 19.
Much smaller, and you can see what sort of destruction and shock wave that a smaller asteroid can produce. It's like Mother Nature is showing us what a small one, a tiny one, really can do. And DA-14 is really only a small asteroid on that scale.
You track them.
Finding asteroids asteroids and tracking them is a worldwide effort, and NASA is the lead agency that coordinates the efforts around the world. I think we have an example. The images taken by observatories really are showing the position of each of the asteroid against a star background. The astronomers report the positions, like latitude, longitude, only it's on the sky, report the positions to the Minor Planet Center, another NASA-funded facility in Cambridge, Massachusetts, which serves as a clearinghouse for all observatories around the world. Then we take the data from them. They help us by computing a preliminary...
Bear with me here.
orbit. We take that data and compute was an amateur group, a very sophisticated amateur group. That's the red dot there showing where their observatory is, and they have state-of-the-art equipment.
There we go.
Find these things. NASA also has many surveys, and I might add that NASA-funded surveys have found a survey telescope in Maui.
Well, let's look at our asteroid right now on the Jinjin Observatory shot. The telescope at this point, is that?
Well, first of all, it's just amazing. Amazing how bright the asteroid is coming. A little guy like this, only 45 meters in diameter, 150 feet, half the size of a football field, and yet it's now accessible to many telling exposure.
Well, we have Ariel Hiri, who's at the observatory right now. She is on the phone. Ariel, are you there?
I am.
Hi, Ariel. Ariel, we
Hi, Gay.
chatted a little bit earlier. Are people excited over there?
Very much so. There's a lot of interest in it. Rick on his own's done, I
We'll try that again a little later.
think, in the last probably half hour, about 5 interviews for different things. We've had newspapers, schools, it's big in the schools. We had the public in today.
Oh, that's just the string of images.
Earlier on this evening, and we did a talk on it then, so it's very big over here. And the weather is perfect. It's about 22
It's just looping.
degrees at the moment, so it's a very, very good evening for doing what we're doing at the moment.
So it is about...
Asteroid about 1:30, and we've not taken our eyes off the screen ever since. And Rick hasn't moved from his spot because we don't want to lose it.
Oh, no.
Can you see it in a small telescope? Can you see it in binoculars? It seems to be amazingly bright
Yes,
for such a
we
small
can
object.
see it with binoculars. You can see it in a small telescope. Grant, who's another astronomer here, has actually attached his camera to one of the telescopes, and he's taking a lot of images that he's going to put together in a slow-mo at the end of it.
Your neck of the woods, what part of the sky are you looking at?
Uh-oh. I got the dogs out watching.
We are looking
Alright, watch.
at area.
Crater, the constellation
Be
crater.
too early.
Okay, all right.
Yeah.
Well, Ariel, thank you so much. We will be coming back to your shot throughout the program, and thank you for bringing it to us. Have a great day out there.
You're welcome. Thank you
All right.
very much.
All right, so that...
So we're probably about here. I'll wait till that comes back on. Yeah, we're probably about
minutes
there.
past the hour.
Crap.
And the visualization you see right there, that's computer simulation, is something that
About there.
we've developed here at JPL. Is a visualization
1800?
tool. We've been
We're now well in the mountains 11-12. So actually we should be
cutting to
we should be
throughout
about there
today.
now.
It's
Just
called
crossing
Eyes on the
geosynchronous
Solar System.
orbit.
And
Because it's 1812 UTC time.
along, Kevin.
Thank you, Gay. I am going to. Here's to be a view of the solar system from above. Looks like a textbook drawing. Is actually models of the solar system and trajectories of our spacecraft and planets inside of a game engine. You can use your mouse.
That's jplnasa.gov.
And I'm now going to click and drag my mouse, and you can see that I'm changing the position of the camera so it looks like I'm flying about our solar system. Anything that has a label is clickable. So before we get to DA14, I have a minute here. I'm going to take you out to Saturn, and we're going to look for another one of our missions that's currently active. There's the Cassini mission. Again, if you click on a label, we will take you to that spacecraft, and if you were at Cassini, this is how Saturn would appear to you at this time. All right, I'm going to take us back home, which will be the center of the solar system, and now I'm going to recreate that view that we showed you earlier. The Earth's label is obstructed by a DA14's label, so I'm going to double click on
That's what the
DA14
filter's on.
and take you into a view of the asteroid. When you double click on a label, we put a camera at the center and we allow you to move about. So right now we have what we call shadow lighting. It's semi-natural. I'm going to go ahead, I'm going to change the lighting model to a full-blown movie light. There it is, a floodlight, if you will. I'm going to go ahead, I'm going to turn off the trajectories of the trails of the spacecraft, and I'm going to turn off the labels. We're getting closer. And then what I'm going to do is, there's a button here we've added that says Ride Along. If you click the Ride Along button, we'll put the asteroid at the bottom of the screen. I call this the Bruce Willis view. And we can zoom in a bit. I'm going to go to 47 degrees. And you will be able to see this as you would if you were riding along with the asteroid. So with that, I would say that remember
That was the one in
to do
Russia.
exactly what I'm doing by visiting that website, and I encourage you to explore not only DA14 as it's on its closest approach, but other objects and planets that are in our solar system. Gay?
All right. Thanks, Kevin. Well, we've been seeing and hearing from
Oops.
observers using optical telescopes
Sorry.
around the world, but DA14 will also be studied by radar
really.
astronomers
You have
as well.
a wonderful
And not
test.
far from here in California's Mojave Desert is the Goldstone Station for NASA's Deep Space Network. JPL's Lance Benner is a radar scientist, and he will be heading out there in just a couple of hours to observe this. Tell us a little bit about what you'll be doing at Goldstone.
Well, we're going to be using the Goldstone Solar System radar to study the physical
Very bad.
properties of 2012 DA14 by measuring its size, its shape, its rotation state, trying to understand its surface roughness, and we'll also be measuring its distance and velocity on multiple occasions over the course of the next several days in an attempt to improve our understanding of its orbit and enable us to compute its motion much farther into the future than we could otherwise.
Now, this is a radar telescope, so it operates differently than all of the telescopes we've been seeing. It sends out a ping,
Yeah,
basically?
well, in effect, I mean, a radar facility is an active form of observation where we transmit a radio beam at the asteroid, and then the radio signal, for example, imagine that this was the asteroid,
Okay.
and the signal goes up, hits the asteroid, bounces off of it, and then comes back down to the ground, and then we switch from transmitting to receiving,
Sorry.
and we make what's effectively a time exposure, and we can
Just,
get a
you know,
radar image.
practicing my
And then as the asteroid rotates, we can
low-tech
build up a
special
sequence of radar
effects.
images over the course of its rotation. and then use that later on to estimate its three-dimensional shape and its spin state.
Check on the
So
time.
this is Tutatis?
This is a scale model of an asteroid called Tutatis, which made a close approach to Earth about 2 months ago on December 12th. It's a much larger object than 2012 DA-14. It's about 4.5 kilometers on its long axis, which is a little bit less than 3 miles. Whereas 2012 DA-14 we think is in the order of 40 to 50 meters, or about half the size of a football field.
We have footage of your data from this particular asteroid that we can show folks, and how you were able to glean some of this information from that.
Yeah, so this shows a sequence of radar images from December 12th that have been turned into an animation. They have a resolution of 4 meters per pixel vertically, and now we're seeing some from December 13th, around the time the asteroid made its closest approach. This is an example of what we can do with the Goldstone Solar System radar. We can get extraordinarily high-resolution images if the objects are close enough and big enough for us to see them like this. To give you a sense of what 4 meters really is, I'm about 1.8 meters tall, so the best resolution we can get with Goldstone is only about double my height.
But you're able to get so much more information.
On an object that's millions of kilometers away from us.
Okay.
So tonight's observations of 2012 DA-14, it'll be extraordinarily bright for us, and we're again planning to get images with a resolution as fine as about 4 meters per pixel.
So walking away from this flyby, we will have so much more information than we had before. We'll know a little bit about perhaps its spin rate, its size.
Yeah, currently there's only limited information available, and the majority of it comes from unpublished work that was done by Nick Moskovitz at MIT.
See all that done
last
from the
year, shortly
laptop?
after the asteroid's discovery.
Put the camera on it.
He found that it has
Camcorder on
a rocky
tripod.
silicate composition similar
I
to
just wish I would have
the
remembered to
composition
adjust
of
the
many
screen.
Earth-approaching asteroids, and also many meteorites that we find. It
Let me
appears
do
to
that
rotate about
now.
once every 6 hours, and as it rotates, its brightness fluctuates considerably, and as a result, we think that it's quite elongated. But at this point, that's all we know, and so we'll find out more. We hope tonight if things go well with the Goldstone observations.
So you only know, or you have a guesstimate of its size. We think it's about 150 feet in diameter, but it could be bigger or smaller.
It's conceivable that it could be somewhat larger or smaller. There aren't really any actual measurements of its size yet.
Keep
Instead,
doing that.
what was done by Nick Moskovitz
Can't
was
make
to
money off of
basically
that,
to
or
get an
it'll
estimate of
be
its
copyright
composition from
infringement.
what's known as visible near-infrared spectroscopy, and then from that to infer,
Forwarding news.
based on what we've seen from previous objects with a similar
Obviously,
composition,
vital
how big this one is likely to be.
survival-oriented news
But
is not.
the uncertainties could easily be several tens of percent.
All right, well, we'll be looking forward to your data, and you'll
No
be heading
money, no
out to Goldstone about 4
compensation,
o'clock today,
not
just a couple hours.
No, I'll be heading out in about an hour.
Oh, really?
Yeah,
Okay.
The Goldstone observation started at 10 after 4, so I need to be out there
There before
that.
then.
Hey, how we
Okay,
doing?
well,
Must
we're
be
looking
down
forward to your
T-minus
data and
5
your
minutes.
information. We'll
All
know
right,
a whole
thank
lot
you so
more.
much.
Okay, so we're just a few minutes away from the closest point that DA-14 will be to the Earth, and we can bring you more images from Gingin, the observatory outside of Perth, Australia. And we're going to take a break just briefly when we bring back Paul Chodas, our scientist with the Near Earth Object team here at JPL.
Oh, sorry. Here's some images.
Paul Chodas is back with us now, and we are back on this
Okay, we're
live
at 5
image
minutes now.
of the shot from Gingin, and we see it's a clear shot.
Beautiful night down there. Now, bear in mind, we can't see the actual craters or any of that in even the largest telescopes. All we're going to see is a point of light moving against the star background.
But it is indeed a really fast-moving object.
Yes, it's a real challenge for astronomers to track this. It's moving so quickly, and in fact, it's so close that you have to figure out where you are on the Earth to figure out to look, what direction to look, what constellation it
Hey, whoa!
We have
just,
a diagram
just,
of yours
yes,
that
over
can
that
actually
level.
show folks where it's coming from,
good,
and we
good,
can cut
good.
to it. This is a diagram that Paul made himself. Here we go.
Yes, so on this diagram, you see the Earth as the green circle, and there's a line going through it, which is the geosynchronous satellite ring. That is the ring of satellites that encircles the Earth, and we're looking at it edge on, which is essentially the equator. asteroid now is passing from the bottom to the top, and there are little time tags indicating at what time it is, at what point, and we're getting very close to the actual closest approach. So it is just below that satellite ring, and very soon it will pass within the ring, which is essentially the time of closest approach.
And folks are worried about that, worried about, is there any possibility that one of the satellites could be affected?
We have checked for that.
We're more worried about it that you don't fucking do your
and checking where all the satellites
do your
will be
PR
at the
work
time,
and
there's
educate
no
the people
chance
to make
that
informed
this asteroid will run
decisions.
into a known satellite.
You're very comfortable with the orbit of this particular
I know all your money's
asteroid.
tied up in killing innocent brown
you
people.
have it down, you're pretty certain where it
Transferring
travels?
their
We've been observing
Leave your
this
wealth
asteroid for
to-
almost a full year, which is a long time for a small object like this, and we know it's
to a few real rich, wealthy
asteroid
pricks that just really
orbiting
would
so accurately
just
to
soon
within
have
100
you all
miles or
dead.
so that we can be confident of these things. The closest satellite will be much farther away, 10 times farther away than our uncertainty.
So it is on an orbit, which would mean that it could come back.
Yes, and in fact, in that diagram, as you recall, you could see the effect of the Earth on the asteroid. There was a significant bending of its trajectory. So the asteroid orbit will change quite a bit after this close approach. Before this close approach, its period around the Sun was 366 days. And after this close approach, it will be 317 days. Its orbit actually will shrink a little, its orbit about the Sun.
So when will it come back,
Okay,
and
we're down
where will
to
it
2
come
minutes. I'm
back
going to
to?
restart.
Well, we'll project that into the future. It
This will
seems that it
take,
could
like,
make a close
36
approach in
hours
year
to upload.
2046, but that it cannot hit. Its orbit is known so accurately that we can